Good morning, dear learners. Today we are here to learn about hypothesis, and here we are going to learn how to test hypothesis. So, testing of hypothesis is a statistical tool, and here, as far as testing of hypothesis is concerned, the learner must be familiar with basic statistics so that it becomes easy for them to understand about hypothesis. So the learners who are not familiar with basics of statistics, they can follow my lectures, which I am going to upload on this channel. So now let us see what is hypothesis and how can we test hypothesis. Looking at the definition and looking at the presentation here, we get to know that testing of hypothesis, it involves or it's a claim or a statement about a population parameter. Let me make it simple for you. Statistic is a proposition to be tested. That means before going on the field work, the researcher has some propositions which are stated in the proposal, and these propositions are to be tested with the help of the statistical tool. So once the researcher completes his or her field work, he or she can test the hypothesis by using methods of testing hypothesis. Here, according to the presentation, it's a claim or a statement about a population parameter. So we have population parameter, like we have mean, we have variance, we got population, right? So these things or these claims are made. The claims are made on population, mean, or a parameter which are to be tested. Let us go to the point now. Here, hypothesis can be tested by drawing the sample. That means usually when we talk about statistics, so in inferential statistics, we study a sample or samples and use the results to generalize on an entire population. So we do not deal with the whole population. We draw the sample in inferential statistics, and the whatever we derive is generalized to the entire population. So we draw the population, and from there we draw the sample. That means first we must find the population of the study, and from there we are trying to draw the sample of the study. So let us see here. Now let us try to understand about calculation or testing of hypothesis with the help of an example. An average age of all college students in a city is 23. So this is an example which states that the average age of all college students in a city is 23. So this is a statement which is to be tested by setting up of null hypothesis and alternate hypothesis. So the null hypothesis is nothing but H0, and alternate hypothesis is nothing but H1. That means we denote null hypothesis as H0 and we denote alternate hypothesis as H1, H2, H3. Likewise, depending on number of hypotheses you have. So null hypothesis here is very important because null hypothesis serves as the baseline to test your hypothesis. So null hypothesis serves as a baseline, and alternate hypothesis is the hypothesis framed by the researcher. So the null hypothesis always says that there is no difference or it is equal, right? So as far as this particular example is concerned, here we get to know that the example states that an average age of all college students in a city is 23. That means there is a particular college and the mean age of college students in this particular college is 23. That makes our null hypothesis. That makes our null hypothesis. Null hypothesis states that mean is equal to 23. But the researcher believes that, or the researcher proposes that mean age of students pursuing education in a particular college is not 23. So here the alternate hypothesis, it says that mean age of the students pursuing education in a particular college is not 23. So you can see the difference. In null hypothesis, it says it is equal to 23, and your hypothesis, that is H1, it says it is not equal to 23. But before we go ahead, let us try to learn like how do we have to test, or what are the ways of testing. Sometimes the researcher just want to find out that there is no difference and there is difference, right? But sometimes the researcher tries to find out that it is less than or more than. So I would suggest the new researchers that they, in the beginning, they should go for two-tailed test for the sake of learning and for the sake of understanding. So here in this example also, we are going to learn two-tailed test. Maybe in the future, in the slides or in the future presentation, we'll also learn about one-tailed test. So for the beginner, we'll start with two-tailed test. Two-tailed here, that means the mean age of the student pursuing education in a particular college can be more than or less than 23. Right? So if the mean age of the students is less than or more than 23, that means our hypothesis is going to be accepted. So this is not so easy. Let us go step by step. Let us see what is the role of null hypothesis here. So null hypothesis plays a crucial role in testing your hypothesis. So here the job of the researcher is to see whether to accept the null hypothesis or whether not to accept the null hypothesis. So let me make it clear. If suppose we do not accept the null hypothesis, that means we are accepting the alternate hypothesis. Right? Suppose we accept the null hypothesis, that means we are rejecting the alternate hypothesis. So this is what is the information which should be taken into consideration while going ahead with testing of hypothesis. So now what we do, we test the hypothesis for significance level. So we'll see what is the significance level. Here it is given. To accept or reject the null hypothesis, we use significance level, that is alpha, which specifies the size of rejection region. So what is alpha? What is the rejection region? We'll get to know by our next slide. Going ahead with the same example, as we said that the mean age of students pursuing college education is 23. So here what the researcher does, the researcher draws a sample of 42 students. The researcher draws the sample of how many students? Draw the sample of 42 students. So the sample size is 42 here. And it reveals that the mean age of these 42 students is 23.8. Suppose their ages are normally distributed with a population standard deviation of 2.4. We can infer at alpha 0.05 that the population mean has changed. So let me make it very easy. Let me make it very easy for you. Here, the sample size is 42. That means n is equal to 42. Our x bar, that is our mean, is 23.8, and our and our standard deviation is 2.4, and we are going to test our hypothesis at alpha 0.05 level. Okay, so here as you can see, we can see the distribution here. So when we say 0.05%, that means let me ask you one thing. Suppose you wrote an exam, and your teacher asked you, what are the chances of you passing the examination? So you may say, teacher, I am 95% confident. I am 100% confident. I am 90% confident. So suppose if you say you are 95% confident, that means 5% you are not confident. So 5% is your rejection level, we can say. So your alpha is 5%. So when we have two tail distribution, you can see the chart here. It has got two tails, one tail to the right and one to the left. So when we talk about 0.5%, that means 0.025% to the right and 0.025% to the left. So it has got two tails. So that's why we divide 0.05 into two sides. One tail is of 0.025 and the other tail is of 0.025, right? And here the thing to note is we are using Z-test. See here, while testing the hypothesis, either you can use Z-test, you can use T-test. So here we are using Z-test. So why are we using the Z-test? So this I shall tell you at the end, okay? Moving ahead with the slides. Here if you see 0.025, students are advised not to jump to the conclusion. We'll see step by step. So here, using the Z distribution, we will see how much is 0.025, how much is 0.025. So using the Z distribution, you can see the chart here where the distribution is given. For 0.025%, if you see the Z distribution table, it is 1.96. 1.96 to the left, 1.96 to the right. And 1.96 to the left is minus 1.96, and 1.96 to the right is plus 1.96. So this is how we got the value 1.96 by using the Z distribution table. Moving ahead with how do we get this Z distribution table and how do we get the value of 1.96. So if you see the chart to the right hand side, we can see that the critical region is 0.025. Okay, if you draw a line in the center, it divides the distribution into two halves, right? Center is nothing but your median. So it divides the distribution into two halves, that is 50% to the left, 50% to the right. So if 0.025% to the left is your critical region, or rejection area, the remaining part in the first half is 0.47%. That means what you do, if it is 50%, if you deduct 0.25% from 50%, it remains 47%, right? At the end of the lecture, I'm going to give you two more information. One is why we are using Z-test and why we call 0.025 as 0.25%, right? So not to get confused, let us go ahead with. So the critical region we have and we have level of confidence. So the white part, what we see 0.47 and 0.47 is the level of confidence, and remaining the shaded part is rejection area of rejection. So when we see 0.475, so when you see the distribution table, you have to find where do we find 0.475. So in the distribution table, we can see 0.475. It is marked. Okay, it is marked. And when you read the Z distribution table, take it to the left. It is also marked. It is 1.9. Then again, if you go upwards to 0.47, it is 0.06. So that means 1.96 to the left, 0.06 on the top. When you add it, that means 1.9 plus 0.06 is 1.96. So this is how we get the Z distribution table, and this is how we got 1.96. And here the learners are advised, please don't come to the conclusion. We'll go step by step. So we have to find two values. One, we are going to calculate the value using the Z distribution test, and also we are going to find the value of Z by using our calculation method. That means we try to find two different values of Z, one with the help of Z distribution table and one with the use of test statistic using formula. Test statistic using formula. Okay, but you got to know how we got 1.96, right? With the help of Z table. Keep it aside, write it somewhere. Okay, then just focus here on the slide. You can check on the right side. We are testing Z by using a formula, by using a statistical formula. So when we apply the formula here, which says Z is equal to X bar minus mu over standard deviation divided by root n. So when you put this thing in the formula, the answer is 2.16. So now we got two values of Z. One is 1.96, the other one is 2.16. 1.96 is the value of Z which we got through using Z distribution table, and 2.16 on the other hand, what we got for the value of Z is the test statistic using the formula. So we have used the formula. So just keep these two things in front, 1.96 and 2.16. With the help of these two values, we are going to test our hypothesis. We are going to conclude now. 1.96 at one hand, 2.16 on the other hand. So 2.16, that is our calculated Z value. 1.96 is the value which we got it from the Z distribution table. Which one is higher? Which one is higher? So we get to know that the calculated value of Z is higher. The calculated value of Z, that is 2.16, is higher than the value which we got by using the Z distribution table, that is 1.96. That means 2.16 is higher than 1.96. If, now pay attention, we are going to conclude. If the calculated value of Z, is higher than the value of Z in the distribution table, then we reject the null hypothesis. Or we say we do not accept the null hypothesis. Making it fair, we do not accept the null hypothesis. So you got the point now. You got the point. when we can accept the null hypothesis or when we fail to accept the null hypothesis. So here in this particular distribution, since z is equal to 2.16, it is more than 1.96. Here we reject the null hypothesis. So what is the good thing about rejecting the null hypothesis here? It means that your hypothesis, that is your H1, or we say the alternate hypothesis, is accepted. That means there is enough evidence that the mean age has changed. There is enough evidence that the mean age has changed. So this particular example we solved by taking alpha as 0.5, that is 5%. The same example you can calculate by using alpha as 0.02% also. So it depends. You can try at both the level at 0.5% and also at 0.02%. So you can conclude by looking at the findings by comparing the z values which are calculated by using a formula with the one found in the z distribution table. So this is the one we calculated the same example by taking alpha as 2%, and here the scene is totally different. Here the scene is totally different, and here the findings are also totally different. Okay, so you can have a look at this example also, but as a beginner you should go for, my advice to the learner is, you should go for two-tailed distribution, and you can try with 5% before, then you can go for 2% also, right? So this brings an end to our discussion on testing of hypothesis, but I had a point to explain here. In the beginning we said that we can test the hypothesis by using either the z statistic or z test, or t test, but here we are using z test. So there are different reasons why do we use the z test or t test. So making it very simple, not going into the technicalities for the beginners, whenever the sample size is more than 30, whenever the sample size is more than 30, we use z test. Whenever the sample size is less than 30, we use the t test. So this is what is required to understand by using whether you're going to use z test or t test. So this brings an end to my lectures.